Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Maths Methods Exam 2 for the Northern Hemisphere Extended Response Questions. Like always, before I start this video, guys, if you want private tutoring, you can always email me through this email, or it'll be in the links in the description. I pretty much tutor physics, chemistry, specialists, and methods. And let's walk through this paper. So question 1. The temperature in an office is controlled for a particular weekday. The temperature at a time t where t is the number of hours after midnight. So we know midnight, so middle of the night. So it'll be 12 a.m. and greater. It's given by this function, this. What are the maximum and minimum temperatures in the office? So straight away, that's easy. So we know our max would be your 19 plus 6. So it'll be 19 plus 6. And your min is your 19 minus 6. Yeah, so this is a quick way, is that right? Yeah, 19 minus 6 and 19 plus 6. So this will be 25, and this one will be 13. Degrees Celsius. Perfect. That's an easy way to do it. It's just to look at the range of the function. And next question. What is the temperature in the office at 6 a.m.? So at 6 a.m., because we start at 12 a.m., and then it'll be 1 a.m., 2 a.m., so it'll be t equals 6 pretty much. So I just need to find t6. So doing that on my calculator, let's define the function. Let's call it a on t. Because I can't write t on t, so yeah, a on t is 19 plus 6 sine pi over 12 times t minus 8. Okay, and we want to find where t is 6. Oh, no, a on 6, actually. A on 6. That's 16, so 16 degrees Celsius. Done. Most of the people working in the office arrive at 8 a.m. So 8 a.m. would be t equals 8. What is the temperature in the office when they arrive? Same thing, so just t on 8. Easy. So what's a on 8? That's 19 degrees. Done. How many hours of the day is the temperature greater or equal than 19? So we want to find where t on t is greater or equal to 19. So one way I would do this is just to graph it. So for example, if I go on graph and say a on x, and we know that the domain is where? From 0 to 24. So given that, so 0, x, 24, and we get, just go menu, Windows, zoom fit. Okay, so we get this, and I'm just going to do a bit zoom out. Okay, we get this. So we want to find how many hours that it's greater or equal to 19. So if I just draw y equals 19, so 19. Okay, we get this. So it's greater than 19 at this point to this point, and we need to find the time difference. So that's easy. So if I can just go to a on t, why is it? Okay, a on t equals 19, and we can solve answer, comma t, given from 0 to less or equal to t to 24. Okay, so these are the points, 20 and 8. So what's 20 minus 8? That's 12 hours. So we can write t equals 12 hours. So how many hours? 12 hours. What is the average rate of change of the temperature in the office between 8 a.m., so 8 a.m.'s t equals 8, and noon, which is 12 p.m. So to get to 12 p.m., it's just t equals 12. Okay, so what is the average rate of change? So it's just t on 12 minus t on 8 all over what's 12 minus 8, which is 4. Yep. So doing this in our calculator. So we're going a on 12 minus a on 8 over 4. That gives you 3 root 3 over 4. So 3 root 3 over 4. Because it's average rate, so it's a rate, it will be degrees Celsius per hour. Perfect. Find t dash of t, easy. So just shift minus in terms of t of a on t, and we get this. So let's write that. So it'll be T dash of T negative pi on 2 cos pi T over 12 plus pi on 3. At what time of the day is the temperature in the office decreasing most rapidly? So at what time of the day is the temperature in the office decreasing most rapidly? So if I have a look at this graph over here, just let's cancel this out. Here we don't need that. Well, here it's increasing, and I think in the middle, so the point over here would be the most where it's rapid, and here, some point over here, this is where it's most decreasing, where the temperature of the office is most decreasing would be over this, the rate over here. So to get this point, what I would do is just go on menu and actually go to analyze graph and go to inflection. So go over here, perfect. So the point of inflection gives you the most steepest of the actual thing. So it occurs at t equals 20. So we can say, well, to actually, because it's 2 marks, what I'm going to say is, to find that, we can just say it's the double derivative of t, letting it equal to 0. And that should give us t equals 20. Yeah. So t equals 20 and t equals some value else, which is the highest steepness, which if I go here, inflection over here, at 8. So t equals 20 and t equals 8. So, but t equals 20 is where it's most decreasing. So, for t equals 20, because look, we start at 12 a.m. So, if we add 12, that will give us 12 p.m. And we just need to add another 8, so it'll be 8 p.m. So, yeah, so your time will be 8 p.m. Done. So, that should be your answer, 8 p.m. Question 2, f of x is this, all reals, find this. Okay, very nice. So let's just define this function, control f of x as x minus 2 squared x minus 5, and we're just trying to find f dash of x, so f of x, and that gives us this. So let's write that down, f dash of x, 3x minus 4, x minus 2, done. For what values of x is f dash of x less than 0? Easy. Let's solve it. So solve where this over here is less than 0, comma x. And gives you the answer over here. Let's write that down. So 2 less or equal to less than 4. That. Find the gradient of the line segment joining the points on the graph of f of x where x equals 1 and x equals 5. Okay, because we do have the points. Isn't it just, so gradient is f of 5 minus f of 1 all over 4. Let's calculate that. So f of 5 minus f of 1 over 4. That gives us 1. So the gradient is 1. Show that the midpoint of the line segment in part CI also lies on the graph of f of x. Okay, so show that the midpoint of the line segment. Okay, so if I draw this line, so we know the gradient and we know a point on it. So let's just get this point over here. So what's the coordinate? It's 1 over. So if I just go on, what's f of 1? So 1, negative 4, that's a point. So, and I know the gradient is 1. So if I create an equation, so y minus 4 equals 1, x minus 1. Y plus 4, x minus 1, y equals x minus 1 minus 4, y equals x minus 5. So this equation over here, we have this equation. And so show that the midpoint. So the midpoint of this line segment, for example, this line looks like this. If you really draw this line, it really looks like this. It would look like, so 0 will be negative 5 over here and 5 over here, and it would just look like this. Look like nicely like this, where this is 5 and this is negative 5. And the midpoint over here is easy. It's to calculate that. It's just adding both the adding both of these two and dividing them by 2. That should give you your midpoint. So we can say your mid x value is 1 plus 5 over 2, which is 3. So 3 is that point, and if we sub that 3 into this equation, we get y mine equals 3 minus 5, which is negative 2. So this over here, so 3, negative 2 is actually your midpoint. That's your midpoint, this point over here. To show then, so we need to show that it lies on the graph of f of x, this midpoint. So you just need to say, does f of 3 actually equal to negative 2? Let's do that. So we know f of x as well. It's this. So if you sub in 3 minus 2 is 1 squared. Yeah, just 3 minus 5 is negative 2. And just let's show some working out. So 3 minus 2 squared and 3 minus 5, which is negative 2, which is therefore negative 2. Done. Yeah, this is perfect. Next question. Find the value of x for which the gradient of the tangent to the graph of f of x is equal to the gradient of the line segment joining the points to the graph of this and that. Okay, so we know that the gradient to these points is dy dx equals 1. Your gradient, which is, or just m equals 1 actually. And we know that the gradient of the f of x is f dash of x is this over here, which is just 3x, so 3x minus 4, x minus 2, equating both of them, so f dash of x equals 1. Solving that, we should get actual answers. So solve the derivative of f of x equal to 1 comma x, and these are your values of x. So let's write those down. So x equals negative 2 root 3 minus 9 over 3, and x equals 2 root 3 plus 9 over 3. Next question. Let g of x be this function. So it's the same function, but we don't know a. Okay. Whereas this one was a equals 5. Okay. Where a is an element of all reals. The coordinates of the stationary points of g are this and that, where p and q are rational numbers. Find the value of p and q. So what I'm going to do here is just create, like, we could actually create 4 simultaneous equations just to be safe. So we can say that we can know, like, that g of 2 must equal 0. That's one equation. We can say that g of p a plus 1 must equal q a minus 2 to the power 3. We can also say that g dash of 2 must equal 0, because that's also a stationary point. So that's your third. And we can also say that g dash of p a plus 1 must equal 0. That's your fourth equation. So writing this in your calculator, so menu, algebra, solve systems of equations, we have 4 equations for values p. We only want p and q. So let's write that. So we're saying that, oh, we haven't even defined it actually. So what's g of x? So g of x is defined as x minus 2 squared x minus a. So, all right, go algebra, not complete the square, wow. Algebra, solve systems of equations for 4 equations for p and q. All right, so we know that g of 2 must equal 0. We also know that g of p times a plus 1 must equal q times a minus 2 squared, cubed actually, yeah. We also need to know that the derivative of g of x is equal to, equal to 0 when x is actually equal to 2. We can copy this. We can say the same thing, but now when p times a plus 1. Enter that, and we get 2 values of p and q. So we get this one over here. But it says us that p and q are rational numbers. This is not irrational, and they didn't say in terms of a, so it can only be these two. So write them down. So p is equal to 2 over 3, and q equals negative 4 over 27. Next question. Show that the gradient of the tangent to the graph of g of x at this point is positive. So, alright. So, the gradient of g of x was what? Didn't we calculate it? So, the gradient is just this. G of x is that. So, and if we sub in, so x equals a, we get this, a minus 2. So, we can say that when dy dx, when x equals a, dy dx equals a minus 2 squared, and we need to show that it's all real to the exception of, that's what values of a is. So we want to show that it's positive. So if we want the gradient to be positive, we know it must be greater than 0. So we have to say that a minus 2 is greater than 0. So if I just draw a graph like this, where this is your a, and this is your graph, and if I draw, so this is 2 here, and it goes like this, it's a positive. Okay. What can we see? Well, when is it greater than 0? Can it be equal to 0? No, it says positive, so yeah, no. So it's greater than 0 at all reals, pretty much everywhere. So we can say a is an element from negative infinity to the point 2. And the point 2 is actually included. That's why we have to say, so we want to make sure it's not included. Union 2 to infinity. Pretty much that's why a. So a is from 2 to, yeah, where a is greater than 0. So this can be written as pretty much a is an element of all reals with the exception of 2. Yeah, so a is greater than 0, all reals, but yeah, except 2. Perfect. Find the coordinates of another point where the tangent to the graph of g is a parallel to the tangent at x equals a. So find the coordinates of another point where the tangent to g of x is parallel to the tangent of x equals a. So we know that a minus 2 squared, that's your gradient at x equals a, is parallel to another part, which if you find dy dx again, which is what? It's just g dash of x. So if we equate these together, let's do that. So we're saying solve this point over here equal to this, comma x. Okay, so x equals a, which we already know, and this is the new point. So this is another coordinate, so we can say x, a minus 8, 3, and we can say g of this point here would give us, what's g of this point? It gives you this, so we can say negative 4, a minus 2 to the power 3, all over 27. And those are the answers, yeah. So these are your coordinates. To write them, we need to write them in coordinate form anyway, so it'll be negative a minus 8 over 3, negative 4, a minus 2 to the power 3, all over 27. And yeah, that's that. So let's just take this over here, done. That's it. Hence, find the distance between the point, this point, and point Q when a is greater than 0. A is greater than 2. So hence, find the distance between this point and point Q. So we know the 2 points now, at least the coordinates, and point Q. And what was point Q? Point Q is this point. So we can just go on our calculator and just say, what is, so if we square root, take this y value minus the y value of the Q, which is Q times a minus 2 to the power 3 all squared plus, now we just get the values of x, so this value of x, minus the value of x for q, which is just p, times a plus 1. And yeah, we all square them, so we squared the whole thing. Given that we already know p and q, so given that if we go here, p and q, we already know those, put them in there, and it gives us this. So absolute value, go down, so we're saying distance is absolute value a minus 2, this. But we don't need the absolute value, what we call the absolute value signs, because we know that a is greater than 2. So we just say d is a minus 2, done. We have to just say a is greater than 2. Perfect. Done. Question 3. A company supplies school with whiteboard pens. The total length of time for which a whiteboard pen can be used for writing before it stops working is called its use time. There are two types of whiteboard pens, grade A and grade B. There are the use time of grade A white pens is normally distributed with a mean of 11 and a standard deviation of 15, which is just 0.25 in hours, because we want it in the same units. Be careful. Find the probability that a grade A whiteboard pen will have a use time that is greater than 10.5 hours. So probability that, say, x is greater than 10.5 hours. So that's easy. So let's just delete this, Control N this whole thing, and go on menu, probability, distributions, and go to, because we're dealing with normal distributions, go to normal CDF. So 10.5 here, to infinity, and our mean value is 11, and our standard deviation is 0.25. And this is your answer. So let's write that down to 3 decimal places, so that'll be 0.977. Next question. The use time for grade P white pen is described by this probability density function, where x is the use time in hours. Determine the expected use time of grade B whiteboards. Give your answer in hours. Correct to 2 decimal places. So we know that the expected value is from 0 to 12 of x f of x dx. So let's do that. So let's actually define the function. So we can say that f of x is x576 times 12 minus x e to the power of x over 6 minus 1. So we just want to find from 0 to 12 x times f of x dx, and it gives us, Control Enter, to 2 decimal places, that's 7.75 hours. Next question. Determine the standard deviation of the use time of grade B white pens. Give your answer to this. So we know that the standard deviation is the variance, the square root of the variance, actually. So we can just say the square root of, we know the formula is x, well, it's actually, yeah, it's the integral from 0 to 12 of x minus your mean, which is what? We already calculated it. So expected value, all squared, times your f of x dx, and that should give you your standard deviation in terms of x. Let's do that. So we're saying your square root of 0 to 12 of x minus this value over here, which is your mean, put that there, all squared, times f of x dx. And that gives you, Control Enter, gives you this. 2 hours to 2 decimal places, that's 2.31. 2.31 hours. Done. Find the probability that a randomly chosen grade B whiteboard pen will have a use time that is greater than 10.5 hours. So x is greater than 10.5, which is just what? From, so we're saying 10.5 to 12 of f of x dx, which is equal to, so 10.5 to 12 f of x dx, and it gives you Control Enter to 4 decimal places. That's 0.1134. Done. A worker at the company finds 2 boxes of whiteboard pens that are not labeled, but knows that one box only contains grade A whiteboard pens and the other contains only grade B white pens. The worker decides to randomly select a whiteboard pen from one of the boxes. If the selected whiteboard pen has a use time that is greater than 10.5, then the box that it will come from will be labeled as A, and the other box will be labeled as B. Otherwise, the box that it came from will be labeled as grade B, and the other will be grade A. Find the probability correct 3 decimal places that the worker labels the box incorrectly. So we want to find the probability that incorrect. So EN, let's say. So if we want it incorrectly, we want him, it will be the probability that, for example, he chooses A, so there will be the probability that he chooses A, but, because we know that the worker decides to run select from one, if the selected whiteboard has a use time that is greater than 10.5, then the box will become A. Because we know, say, probably the A, but we know that when it's greater than 10.5, it's A, but we want to make sure it's incorrect, so we want to make it, let's say X is less or equal to 10.5, plus the probability of B intersection. Now, we want to misspell B. Well, B would be then X is greater than 10.5. So, what do we know? So, we know the probability of A. What's the probability of A? It's just half, because he's choosing randomly one of those boxes. It'll be half times your X is less than 10.5 for A. Make sure it's A, actually. These are A. So, XA 10.5. So, when A is less than 10.5, when is that? If we go here. Okay, so this is A, but this is greater than 10.5. Just, yeah, we can just say 1 minus that. And we should get, so it'll be 0.023. Yeah, 0.2. You can say 0.02. So 0.023. Yep. Plus, again, half probably of B times where B is greater now than 10.5. And we already know that. That's this. So it'll be 0.1134. So that will be overall, we do that. So it'll be 0.5 times 1 minus, where is it? This one. Plus 0.5 times this over here. And we get final answer this. So, but we want it to 3 decimal places, so that'll be 0.068. Done. Find the probability correct to 3 decimal places that the whiteboard pen selected was grade B, so we want probability that it's grade B, given that the boxes have been labeled incorrectly, so incorrectly, which is just the probability of B intersection incorrectly all over the probability that they are incorrectly. Now, we already calculate the probability that B incorrectly is this, just this point over here, which would be half times 0.1134. All of what's the probability of being incorrectly? We've already calculated that. That's 0.068. So your final answer should be, so it's this one over here. Copy that. Take this over here. Enter. And we get this over here. So 3 decimal places, that'll be 0.833. There, that looks good. Next question. So as a whiteboard pen ages, its tip may dry to the point where the whiteboard becomes defective. The company has stock that is 2 years old, and at that age, it is known that 5% of the grade A whiteboard pens will be defective. A school purchases a box of grade A whiteboard pens that is 2 years and old, and a class of 26 students in the first class use them. And if every student receives a whiteboard pen from this box, find the probability that correct 5 decimal places that at least one. So we want the probability that at least one student will receive the defective pen. So okay, let's say X is defectiveness and it's binomially distributed. And how many students? Well, there are 26 students. Yes, yeah. The class of 26. Yep, 20. And we know that probably being defective is 0.05. So doing this, it's just, we can just rewrite it as 1 minus the probability of x is less than 1, or just 1 minus probability of x equals 0. Yeah, so that should equal to what? Just go menu, probability distributions, and we go to binomial PDF. So number of trials is 26, probably success is 0.05, and we know the x value is 0. So what's 1 minus that? We get this. So 0. To what was it? 4 decimal place, so 0.7365. 0.7365 looks good. Yeah. Have I done anything wrong? Nah. Looks good. Perfect. Let PA be the random variable of the distribution of a sample proportion of defective grade A whiteboard pens in a box of 100. The boxes come from the stock that is 2 years old. Then find this. 4 decimal places. Do not use normal explanation. Okay, so P hat is equal to x over n. And we know now n is 100. So if I'm rewriting this whole probability, P hat is 0.04. What's 0.04 equals x over 100? It's 4. Yeah, so we can say x is greater than 4. Then this one would be x is less than 8. Writing that. So if I'm just going to draw this like a diagram. So let's say this is 4. This is 8. So we're saying it's greater than 4, less than 8. So the intersection is probably that x 4 less than x less than 8. Just minus this over here. All over probability that x is less than 8. Now, because it's normal, it's actually not normal distribution because we can't use it, but we're using binomial. So we rewrite this as probability as, wait, if this was 4, this was 8, it'll be 5 less than x less than 7, less or equal. Yeah, so let me write that again. So 5 less or equal, x less or equal to 7, all over the probability that x is less or equal to 7. That's that. And yeah, let's now use binomial distributions to do that. So go on menu, go on probability distributions, and let's go to binomial CDF first. So number of trials is 100 now. Probability of success is still 0.05. Your lower bound here is 5 and your upper bound is 7, and it gives you this. And let's do it again. So probability distributions, normal CF. Your number of trials is 100. Probability of success is 0.05. Your lower bound here is 0 and your upper bound is 7. And it gives you this, and we're just saying this divided by this. Control enter, and it gives you this. So to 4 decimal places, that's 0.5000. Done. A box of 100 grade A whiteboard pens that is 2 years old is selected. Okay. And it's found that 6 of the whiteboard pens are defective. Determine 90% confidence interval for the population proportion from this sample. Okay. Well, you just can use your calculator for this. You don't even need to actually. Yeah. Wow, this is very easy to, yeah, you can just use your calculator. So again, just, I don't know, if we just, because it's 2 mark, we can just say that P hat is 6 over 100, which is what, like 3 over 50, yeah? And we just write the formula, like, your confidence interval would be P hat minus Z, square root P 1 minus P hat over N, P hat plus Z, P1 minus P over N. Now, I'm just writing this because it's 2 marks, and I think just showing some working out to get the marks. Yeah. So now I'm just doing it in your calculator. Very easy. Just go on menu, go on statistics, confidence interval, go on 1 probability interval. Our success here is 6, and the number of tries is 100. And our C interval is we want 90%. So just put a 0 over here, press OK, Control Enter, and done. And we want it to 2 decimal places, so that will be 0.02, 0.02, 1, 0. Yeah, that is your confidence interval. Question 4. F of x is from 0 to 16 is that. Find the value of x at which f has a maximum and state the maximum value. So wait, find the value of x for which f has a maximum and state the value of maximum. Very easy. So this is just to find this function. So f of x is 4 root x minus x, and we want to go on menu calculus maximum of f of x comma x, given that it's 0 to 16. Enter, and x is equal to 4. So your maximum value at x, so it occurs at x equals 4. And what's our maximum value? It's just what's at f of 4. Ooh. So, and also occurs at 4. Is that right? So find the value of x for which it has a maximum and state the value of the maximum. So f of 4 is that. Is that right? Okay, so also your max value occurs at 4. Just want to double check it because I'm not too sure. I just want to graph it right now. Okay, your max value 1, 2, 3, 4. Perfect. Yeah, done. Sketch the graph. Very nice and easy. We've just done it. So, but let's restrict the domain from 0 to 16. And let's make it the same everything. Like, so if I go menu and let's go Windows and go Windows settings. Well, this is 0, 16. Your Y scale is 2. Your Y min is 0. Your Y max is 7, and your scale is 1. Yeah. Well, the scale each box. So each scale that's 2, and that's 1. Okay. Okay, and we get this, and we just want to go on view grid. We want line grid. Aha, this is the perfect drawing. So just draw this identical to what we're doing here. So we start at 0 here, and it finishes at 16. We know that this point over here is here, this point is over here, this point's over here, and this point over here is at 4. 1, 2, 3, 4. So it's at this point, this point. We also know this point over here, this point over here, this, and this. So now sketching this, pointing the dots, we've got this. Yeah, it just says sketch the graph. So yeah, just sketch it like this. Next question. Find the area of the region enclosed by the graph of f and the x-axis. Easy, so it's just from 0 to 16. Was it 0 to 16? Yeah, 0 to 16 of f of x and dx. So area from 0 to 16 of f of x dx. It's this. So we can write 128 over 3 units squared. Let x be the point this. And triangles can be formed with the vertices O, X, and this point, where C is the point on the graph. Find the value of C for which your triangle OC has a maximum area, and find this maximum area. Okay, so if I'm drawing, so this is O, this over here is, what is it? X. So this point is X, and your C value would be around these points over here. So let's check over here, and it will form a triangle. Perfect. Just for triangle. All right, so easy. So what can we know? Well, the formula of the triangle, the area, is in terms of actual x. Wait, a? Yeah, we can say x. And let's just call it area. It's half your base, which is 16 minus 0, which is a 16. 16 times your height, which is this point over here. Well, it's not 4, but we're just saying it's the coordinates CF of C. So it's f of C. we call it f of x to be safe. Then we calculate x, and that's our c value. Is that right? So area is that. Yeah, and in terms of x, we'll write it. Done. So area of x is just 8 f of x. So a dash of x, when it equals 0 and blah, 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 we should get the value of c. So the fastest way I'm going to do this is, okay, this is the equation. So it's a times f of x. It's this. And what's the, if we go menu, we go to calculus, we go to maximum of this over here, comma x, given that we know it's from 0 to 16, and we get x equals 4. So your c value is 4. And what about, so find the value of c4, which triangle has a maximum area, and find the maximum area. So we know that area is this. So just be subbing this in, 32. So your max area is 32 units squared. Done. Let a and b be two values in the domain of f such that f of b equals f of a, and assume that b is greater than a. So just let me just use my calculator here, and we illustrate this. So we want f of b equaling f of a. And okay, let's write this, and let's do some working out. So 4 root b minus b equals 4 root a minus a. I'm going to bring the roots on the left-hand side. So 4 root b minus 4 root a, b minus a. And take 4 common factors, so root b minus root a. And you should know that this over here, think of it as a perfect square. Yeah, so if you're going to perfect square this, it's just going to be root b minus root a, root b plus root a. And we know that these two cancel out, so leaving us with 4 equals root b plus root a. And let's calculate for b, so it will be 4 minus root a, root b. And squaring both sides, we get 4 minus root a squared equals b. Now, because we want it, well, it looks different, but if you can take a common factor of negative out, because it's being squared, it cancels out. So we can just say it's root a minus 4 squared equals b. Yeah, that's that. A rectangle is formed with vertices this, and that. Find the area of the rectangle in terms of a. So let's just say this rectangle is like this. And we know, let's say this is a, this is b. And this is, we know this is f of a, this is f of b. So the area of the rectangle would be what? It will be, in terms of a, so let's write it a. In terms of a, it's what? It's b minus a. Well, it's this length over here, and this height, which is f of a. We can write, f of a. And yeah, let's do it in a calculator. So we're saying, what's b minus a times f of a? And we get this. Now we know we want it in terms of a, so we know the value. We know what b is actually. B is, they've given it to us, so b is equal to square root a minus 4 squared. And it gives us this. So this is your in terms of a. So let's write that down. So a on a, it's 8a, 3 over 2 minus 48, a plus 64 root a. That's that. Find the values of a and b for which a rectangle has a maximum area. Okay, so we want maximum area. Easy. So what's a dash of a? So that'll be 8a through a dash of a is what? So shift minus in terms of a of this function. Oh, no, this is not good. A over here, this over here, and gives you this. So 12 root a plus 32 root a minus 48. Okay, and we want a dash of a equal 0. So a for max is, I'm just going to use my calculator, go on menu, go on calculus, go maximum of this over here, comma a, given that a should be only from 0 to 16 still, and a is this. So we can write that down. negative 8 root 3 minus 2 over 3. Now we know that to find the value of b, so find the values of a where the b is maximum. So we know b is what? This. b is root a minus 4 squared. So b equals root a, will be square root negative 8 3 minus 2 over 3 minus 4 all squared. So b would be, okay, so if I just take this over here, given a is this, and it gives us that. So 8 root 3 over 3 plus 16 over 3. Those are your values. Wow. Next question. Find the value of the maximum area in a form of this, where m and n and p are positive integers. Okay, so done. That's easy. Well, we know that this over here is our area, given putting this in, and that gives us this. Perfect. Let's write that. It's 2 marks. So what the best thing we'll do here is, we know area is negative 8 over 3 minus 2 over 3, and that should equal 128 root 3 or 9. Done. So the last question. Okay, perfect. A trapezium ODBX, okay, is formed with vertices at O. So this is 16, B is that, and this in the diagram below, where D and B are parallel to OX. Okay. Find the values of A. Find the value of A, actually, for which the trapezium has a maximum area AT, and find this maximum area. Easy. So now, area of the trapezium. So for area of a trapezium is half this value, like this length over here, this value. So we need to add these two values in. Well, it's just 16 plus b minus a times your height, the height of the thing, which is just at f of a. We can write f of a. So writing this whole thing, yeah, we should, that's your area. And yeah, look, so area is, let's write this in our calculator. So we can say half 16 plus b minus a times f of a. And that gives us this. Now we know b, so let's put b at least in. So if I bring this over here, b is such a mess. B is this. Writing this, it gives you this. So let's write that. So in terms of a, so a on a, for a, 3 over 2 minus 32a plus 64 root a. So find the value of a for which it appears as a maximum. Okay, so then what's a dash on a equals 0, and a should, let's do that, go menu, algebra, no, calculus maximum of this, a from 0 to 16, and we get 16 over 9, so 16 on 9, and so a, find this maximum area, so what's a on 16 on 9? That's this over here, given a is that. It's this, 1024 over 27 unit squared. Find AT over AT, where A is the area of the region enclosed by the graph of F and the x-axis. Okay, so it's just, we've already calculated AT, which is 1024, 27, and A is the region enclosed. We've already calculated that. Where was it? Enclosed. This one, 128 over 3. 128 over 3. 128 over 3, which is equal to, let's just do that. So we're saying this value over here, put it over here, and the other one, where is it? This one over here, put it over here, and that gives us 8 over 9. 8 over 9, that's your answer. Yeah, I think that's it. Look, I'm not gonna lie, this exam was nice. Like, the questions weren't that bad. Like, the last question was alright. Like, it wasn't too hard. It was just knowing how to use your CAS calculator, and yeah, Hope you guys enjoyed this video and make sure to take care of yourself. Bye bye.